Alright class, welcome to Math 2020 video for section 5.3, which we're going to investigate the area of three two-dimensional shapes. First, parallelograms, then triangles, and then trapezoids. And for this lesson you'll need three pieces of paper like this, and three notebook papers like this, a ruler, and a writing thing. What we're going to do in this section is we're going to model a type of investigation that will occur throughout other sections in the rest of the course. We need to connect the area of a parallelogram to the area of a rectangle. In sections 5.1 and 5.2 we studied the area of rectangles as being some amount of tiled square units. The rectangle is has the same structure as a square, in that all the angles are 90 degrees, and so square units can fit nicely into rectangles. But parallelograms and triangles and trapezoids are not nice rectangles. The square units won't fit nicely into them. And so we need to think about how we can connect the area of a parallelogram, for example, to the area of a rectangle. Find the area of the rectangle and then connect that back to the area of the parallelogram. So there's a connection that we need to make. In order to make this connection, we're going to cut out two examples of parallelograms, and we will arrange cut up the pieces of the parallelogram into a way that we can make a rectangle, and then compare the dimensions between the rectangle and the dimensions between the parallelogram, and see what we can do to find the area of a parallelogram. Okay? So with our notebook paper we have it titled Area of Parallelograms, Triangles, and Trapezoids, and we're going to start with our investigation of parallelograms. Now in order to see what parallelograms, the area of a parallelogram, we need to look at the dimensions that we can measure. Okay? And so here on this paper I'm going to draw an example of a parallelogram. Where both sets of opposite sides are parallel, both sets of opposite sides have the same length, and it's also a four-sided figure. Okay, so we'll pretend that that's a parallelogram. And the things that you can measure on the parallelogram are things like this, where we can measure the base, we can measure the slant height, and we can measure the height. Okay, so I'll go ahead and label those now. Measure the base, we can measure the slant height, and we can measure the actual height from the bottom to the top at a right angle. Okay. So this distance right here is the actual height. Okay. So we have these attributes that you can measure. And so what we need to do is we need to transform this parallelogram into a rectangle, because we know the area of the rectangle. And so what I've done is I've labeled a piece of paper for the video demonstration purposes, and for your purposes you can just take a regular notebook paper or printer paper and just draw these on here. But you can just draw them on and cut them out. What we're going to do is we're going to draw the long side as a base with this parallelogram. So I'd recommend cutting out a couple of them. Okay, so here's my ruler to use as a straight edge here. Okay, I want to draw another straight edge probably about here. I don't want to make it that big. Okay, so we'll make it smaller. But I'm just kind of sketching out a parallelogram, making all of the right angles the same. What you can do is you can use the shapes that are uploaded to the course calendar. So on the course calendar for the today and for Friday, for the next lesson, we have shapes that are already drawn out, and you can print those out, or you can just cut out your own parallelogram. And cut out my parallelogram. Okay, and so I have a nice little parallelogram here. This is the long side as the base. Okay. And so I've drawn the long side as the base of my example. So I need to transform this parallelogram into a rectangle because I know what the area of that is. So what I'm going to do here, so I'm going to trace my parallelogram onto my notebook paper. Give it a little bit more room here. Okay, so we'll trace it because we want to know the original dimensions. And then we're going to cut this piece cut out up into make it a rectangle. Okay, so here's my parallelogram. Okay. Traced it on my paper, and I'm going to cut it up, transform it into a rectangle. Okay. And so what your exploration is, and I'll demonstrate this here, is you want to take this, cut it up, make it a rectangle. So I noticed that if I have this parallelogram and I cut off this part right here, okay, so it's at a right angle, cut off a triangle there, and I move the triangle over to this side, I will have a matching side length right here. And that means that they will always be matching because they're parallel. And I've made myself a rectangle. Okay, so this is what you do with the shapes for triangles and trapezoids. We'll cut up the shape into making it a rectangle. Now once I do that, I'm going to tape down my transformed shape. And so I'm going to tape it down and transform. So you'll also need some Scotch tape. Okay. So now it's a rectangle. Now what happened to our dimensions? Now we call the bottom of the parallelogram the base, from here to here. Okay, the rectangle has length and width usually. And so for purposes of this lesson, we're going to also call this the base of the rectangle. Base or length. Okay. And the height of this parallelogram is here. And I'm using the height because the height of my rectangle is here. Or the width. Okay. Alright. Notice that when I cut off this part right here, the base was this long from here to here, but this part is over here now. And so this part has been preserved, this distance here. Okay, now that you've cut out off your side here, put it together, we can tape it down with some tape right here. And we can label, we want to find now the area of this parallelogram here when it's transformed as a rectangle. I've drawn in the base, and I've labeled the height. Because rectangles have a length and a width. Length and width that you multiply together to get the area. Now what we want to do is that when we've noticed that the baseline the length of the base has not changed at all when I've cut off this piece and moved over to here. That's still the same. The height has also not changed. And so I can conclude that the area of the parallelogram, at least with the long side as the base, is the same as the area of a rectangle with the same base and height. Okay, so area here is equal to the base times the height. On our next exploration, we're going to draw a parallelogram where the short side is at the base. And so we draw kind of like tilted here. Draw a tilted parallelogram. But it's important that this parallelogram be taller, okay, then you can have, so I'm going to move this up to here. So when you cut off this side here, see, mine's not tilted enough, you cut off this side here, move it over, you can still have one like that. I want to draw it so that it's more tilted than that, so you can't cut it off in that fashion. In this way. Really tilted. There we go. Okay, so notice I cannot cut my parallelogram from here to here. See, if I cut off the side here, then it will cut through the parallelogram. So I can't use the same method as I did before. So once we cut our parallelogram out, we will have to think of a different way to make it into a rectangle. Okay, so go ahead and make a skinny parallelogram. The short side is the base. Cut that out. So skinny that you can't even cut off the side. And move it over to make the rectangle. Okay. Now once we have our long skinny one, we need to keep this as the base. We can't turn it like this and then do the same method as before. Because if we cut it here, it will not make a rectangle when we move the piece over. So we have to think of a different way. So go ahead and pause the video and think of a different way to cut up this parallelogram. You can look at your book if you want, and then resume it when you're done. Okay, now that you've done that, go ahead and trace this parallelogram here. Okay, so we have our parallelogram traced. We need to transform it into a rectangle, but it's too skinny to cut off like I did before, cutting off that part. So what we can do is we can cut into little parts here, cut into 3 little parts this way. And now we have little parallelograms. Oops, that one cut a little bit off. Okay, so when sometimes you make a mistake like that, and tape it back together. put some tape on the back. You tape it back together and then you can make a new cut. Okay. You cut this parallel like that. There we go. Okay. So we'll pretend that those are parallel. There we go. There's a little parallelogram there. This one I'll try to make parallel here too. It just kind of makes adjustments as you need. Okay. So we have 3 parallelograms here. Okay, when you put them together, they make that parallelogram. Okay, so we've cut them up into 3 parts. And now I can cut off the sides like I did up here. Okay, so we've cut off those little ends there, and we're going to move them over to this side here. So I have a little rectangle there, move it over to this side here, so a little rectangle there, move it over to this side here, so a little rectangle there. Okay, and notice that they are now staggered steps. Okay, and so I'm going to trace the staggered steps right here. Okay, move them over here. Tracing them over here. Okay, staggered steps. Okay, now when they are staggered here, we want to make a rectangle and squish them all back together this way. Okay, so we've made a rectangle right here. Get our tape and tape it all down. They were staggered steps, but now we're squishing them back together to make a rectangle. When you compare this rectangle to the original parallelogram, okay. Now, when we compare this one to the original parallelogram, we're going to pretend that all this is a rectangle now. It's a rectangle. Okay, my tape slipped a little bit. Okay, so it's a big rectangle. Now, this is the base right here, parallelogram. This is the base of the rectangle. Notice that when even though we've cut it, it's placed. It has not lost any length because we just switched it to over here. Okay. Okay, length not lost. So the base of the parallelogram is the same as the base of this new modified rectangle. And the height of the parallelogram is the distance from the bottom to the top at a right angle. So I'm going to go from this bottom to this top at a right angle. So I'm going to bring it out here and go up this way. Okay. This is the height. Now the height of this parallelogram has not changed because the height is still the same here and here. And the height is still right here, this distance. Okay, so the height hasn't changed. So it doesn't matter, it looks like the area of this parallelogram is still base times height. No matter if it was the base is the long side or the short side. Now it's important to know that this is true for no matter how you orient your parallelogram, because in the homework you're going to have parallelograms where you are given this is the base and you're given this height at a funky angle. So you got to turn your book around to see the bases and the heights from the different parts. Okay, so that you know how to orient your parallelogram to get the right information for your base and height. Okay, so it turns out that parallelograms, all you have to do is measure their base and height, multiply them together, and you have their area. In this video, we're going to investigate the area of a triangle. A triangle, again, has an angle, a slanted side, that is, so that you can not have nice little squares for your units. So how do we handle that? Okay. First, we're going to draw a right triangle. In our investigation, there's several types of triangles, and the easier one to find is the area of the right triangle. Okay, where the one angle is right. Okay. So I kind of drew a sketch out there. You can firm it up with this ruler. Make the lines nice and neat. Okay, so this is a right triangle. What I'm going to do is I'm going to cut this one out, and we'll see how to investigate it here. Find the area of a right triangle. So here I have my right triangle, and I'm going to make it a rectangle as my goal, because I know the area of a rectangle. I also know the area of a parallelogram, so that's also available to me using deductive thinking. Since I know the area of the rectangle, I know the area of the... Since I know the area formula for the rectangle, I know the area formula for the parallelogram, which I can now use for an area formula for the triangle. So if I have a parallelogram, then I can use that. But since the right triangle is right, it looks like I'm going to try and connect it to a regular rectangle. And so because I have a right triangle here in my notes, I'm going to trace it. Okay. So I'm looking for the area of this shape here. Connecting it to a rectangle, well, we need to connect it to a rectangle, and I don't want to tell you the answer quite yet. But go ahead and pause the video and try and find the answer yourself. You want to be able to cut this up, you can even double it or halve it into different shapes as well. That's now available to us for these triangles. Okay, so go ahead and pause, explore the way to find a rectangle, and then we'll connect it back to the triangle for the area. Okay, now that you have explored it on your own, this triangle really looks like half of a rectangle. Okay, so this is the right triangle. I'm going to double it. I'm going to trace what I have here. Double it to make a rectangle. Okay, so Okay, so I'm doing this twice to emphasize the doubling, even though I won't use all of it for my picture. So we double it to find the area. Okay, this is a rectangle now. Okay. Well, when I find the area of this rectangle, I need to look at the dimensions of my triangle. So my triangle here has a base, and it also has a height. Okay. The base and height are preserved in the doubling. That's still the base, and this is still the height. Okay. The only thing is that I've doubled it. So the area of the rectangle here is equal to base times height, or length times width, if you will. But the area of the triangle is only going to be one copy of it. Okay, so we're going to tape that down right here. And we know that the area is just one copy. The area of the rectangle is the same as the area of two copies of right triangle. So that's also equal to base times height, which means that the area of one copy of the right triangle is equal to 1/2 base times height. Okay. Because this right here is still the base, and this right here is still the height. Okay. So we have kind of a preliminary formula here. Let's verify with other types of triangles. So the next type of triangle that I'm going to try and investigate is an isosceles triangle. Okay. So I'll kind of sketch it out here. The important part of the isosceles triangle is that the side lengths are the same. Okay. So we have an isosceles triangle here to cut out. I'm going to find the midpoint using some estimations here. So I'm going to go from here to here is 0 to 6, and so 3, so that's actually pretty good on my midpoint. So I use the midpoint, I can make each of these side lengths the same. Okay. Alright, that's an isosceles triangle. It's not equilateral because the side lengths are 5 centimeters there. So I'm going to cut it out. Alright, we have our isosceles triangle here. And we need to make it into a rectangle, or a parallelogram. What you can do is the same approach by doubling, by taking this and a copy and making it out this big. Okay, but since we did that process already, there's going to be another process that we can use. So we can cut this base in half, and it will go right up to the apex of the triangle, or the top point. Okay, so if you cut the base in half, I can take these pieces and switch them to make a rectangle. Okay. So with the isosceles triangle, let me trace it here. And this is one method of exploration we can do. Okay, isosceles triangle. Now I'm going to switch I'm going to make the transformation by cutting the base in half and flipping it. The other half to make a rectangle. Okay, because this is the base right here. And the height is right here. I'm going to take my rectangle down. This. Okay. So here's my rectangle. Now this part right here, the rectangle is at the base and the height. The height is the same. This distance here is the same as this distance here. Height hasn't changed at all. But the base is it used to be this long, now it's this long. So that's half of the base. Okay, so we have half the base now for our rectangle base. Okay. So the area of the triangle, of the rectangle, we can connect it back to the triangle, is equal to base times height. Now the area of the rectangle, area of the triangle, okay, is the same as this area here, which is 1/2 the base times the height. Okay, I'm replacing the base of the rectangle, so b sub r and h sub r. H sub r and h sub t are the same. Triangle height and height of the rectangle are the same. The base of the rectangle is the same as half the base of the triangle. Okay. So again, we have the half base times height formula. The next type of triangle that we'll investigate is the scalene triangle. We call it the scalene triangle is one that has all different side lengths. So I'm going to sketch one out here, and then form up these lines with my ruler, make them straight. All 3 different side lengths. All 3 sides different lengths. Scalene triangle. And so we'll cut this scalene triangle out, and we need to make it into a rectangle or parallelogram. Okay. Here's our scalene triangle. Now we could double it again and have another triangle here and make a parallelogram. We could chop it in half, but the base, it's harder to see the base in half. So let's go ahead and draw in our height here. And I'll show you a third way to cut up the triangle. Height is the distance from the bottom to the top at a right angle. Now the top is the apex of the triangle. The bottom is anywhere on the base, but it has to be on a certain point where it makes a right angle. Now the height is this distance here. And I'm going to just take a look at a measurement. And it's about 3 centimeters. So half of the height is about 1.5 centimeters, which is right about here. What you can do is you can cut out the height in half, like this. Okay. You cut the height in half, and then you distribute this piece here to that side, and this piece here to that side. So let me cut this piece along the height. Okay. And this piece will fit nicely over here because it's from the same line, same angle, same segment. And this piece will fit nicely over here. It's also from the same line segment. They're going to be parallel here. That means that they'll fit together nicely. Okay, so I'm going to go ahead and trace my triangle. And I'm going to use the method where I cut the height in half. Okay. So this is my scalene triangle, traced. And I'm going to transform it into a rectangle. Now I transform it by cutting the height in half. I'm going to put the other pieces down by the base. Okay, in this manner. Okay, and I'll tape them there. There's one piece, and here's the second piece. Okay, now I have a rectangle. It's a skinny rectangle. The base hasn't changed at all. Okay, so notice that this is the base. We're attenuating to these dimensions so that we can find the formula. Okay, and in the triangle there's some slant heights here too. Now the base hasn't changed at all. Notice that's just all the bottom. But the height has changed. That right there is half height. Okay. So the height of the rectangle is equal to half the height of the triangle. So the formula for the area of this rectangle, the area of the rectangle is equal to the base times the height. Base of the rectangle times the height of the rectangle. Okay, so the corresponding area of the triangle is equal to, now the base of the rectangle is still the same, so it'll be the same as the base of the triangle, multiplied by the height of the rectangle, which is half the height of the triangle. Which means that we have base times half height, which is equal to half base times height. If you use the commutative property, okay, and this right here, again, is a formula. So we're kind of seeing a pattern here. The last triangle that we're going to observe, that we have to check, is an obtuse triangle. Now the obtuse triangle is very long and skinny. Where this is an obtuse angle. So that's the tricky part. How do we handle that? We need to make it into a rectangle. So let me solidify things here with my ruler, because this line looks a little here. Okay. So now it should be all straight. We need to cut it up to make it a rectangle. We need to make sure that we start with our original base and height as well. Now we're going to draw the obtuse triangle, trace it into our notes here. Now so that we can cut it up. As I am tracing and drawing and exploring on my own here, I want you guys explore on your own. Pause the video and make this into a rectangle or parallelogram. Okay, now that you've done some exploration, we have the triangle here. We need to make it into a rectangle or a parallelogram. We can use the doubling method and have a parallelogram here. Okay. Let's go ahead and see if we can cut it up somehow. Now the height of the base, let's see if we can cut the base in half. The height in half. Yeah, so we cut the height in half. Let's do that. Okay, and we can put our triangle here. Yeah, so we'll pretend that the height was cut in half. Let's see, where was it before here? Yeah, because we want to meet these two together. So these two are together. It's a little bit long, but so it's probably not exactly in half. We get a parallelogram. Cutting the height in half on the top one, we split it into a rectangle. But let's just go ahead and cut it into a parallelogram, and then we'll call it good. And the notes on this one will be the same as the one above. Okay. Cut height in half. So when we cut the height in half, we get a parallelogram. And the area of the parallelogram is equal to base times height. Now the base is right here on the triangle, and the base over here is on the triangle. It's different. They're the same. Same. But the height, which is right here, compared to here, is half. Okay. So the area of triangle is equal to 1/2 base times height. So half height. So let's go ahead and do half height here. So we have base times half height, which is equal to 1/2 base times height. Okay, in all these cases, the area of the triangle worked out to be 1/2 base times height. What's great is that you probably knew this already, but you have 4 ways to prove it. Well, 3 ways. Okay. 3 or 4 ways to prove it. So that's what's helpful and powerful about this mathematics. Alright class, we have the formula for our last shape, the area of a trapezoid. So I'll draw a generic trapezoid here. Trapezoid is a quadrilateral with one set of parallel sides. So usually we draw it as a trapezoid with the top and bottom as the parallel sides. So I'm going to make my line straight here and cut out my trapezoid. The approach will be the same. Make the trapezoid into a rectangle or parallelogram. And we can also use triangles to help us find the area of the trapezoid. I'll show you 2 approaches for this video, and you can refer to the handout on course calendar for 4 other approaches to finding the area of the trapezoid, which are quite fascinating. But I'm going to show you the most basic on this video. Okay, so here I have my trapezoid, and I'm going to trace it, and on my notebook, so we can show how the original shape goes, which will label some parts on the original shape. Okay, so here's our original shape, This bottom base is usually called base 1. This right here is the top base, which we usually call base 2. Okay, so we have the top and the bottom. Then the height, again, is from the bottom to the top, bottom base to top base, at a right angle. Okay, and we'll use these three characteristics to find the formula for the area of a trapezoid. It's very similar to parallelogram and triangle, but we have two bases in this one. Okay, so that's the tricky part. So here's our trapezoid. What we're going to do for this one is we're going to copy it. I'm going to put it down here a little bit. So we need to make a copy of it. So I take my base, or my trapezoid, and I make two copies. Okay. Right here. And this is where I'll tape my trapezoid. Okay. So I transformed it by making two copies. This is similar to what we've done with one of the triangle approaches. Okay, now notice that the base, this is a parallelogram now. The area of the parallelogram is base times height. Okay. Now the base of this parallelogram stretches all the way here. So that's the base of the parallelogram. So we label it BP. And the area of the trapezoid, so we have the area of the parallelogram is the area of two trapezoids. Oh yeah, and here's the height. Okay, so that's the area of two traps. So the area of two trapezoids is equal to, let's break down our base and height here according to dimensions of the trapezoid itself. This one is right here was base 2 of the trapezoid, and this one right here was base 1 of the trapezoid. Okay. And the height of the parallelogram is equal to the height of the trapezoid because it haven't made it bigger or smaller at all. Okay, so the area of two trapezoids is the base times the height. So the base is going to be the sum of base 2 and base 1. And then I need to multiply that by the height. Okay, since they're interchangeable, we'll just label it as base 1 plus base 2 times height. Now that's the area of two trapezoids, two copies of it. The area of one copy is going to be half of that. Half of base 1 plus base 2 times height. So you can write it as half base 1 plus base 2 times height, or half height times base 1 plus base 2. Yeah, that's getting kind of messy there. Correction tape. Half height times base 1 plus base 2. Or you can do base 1 plus base 2 times height, all divided by 2. Okay? So there's several approaches to the area formula. Okay, so here's way 1, here's way 2. Okay. I'm going to go ahead and draw another trapezoid on here. So we can make another copy of it. Another generic trapezoid. cut it out. I'm actually going to make it a bit shorter than what I drew it here. So we got, make a copy of it again. We're actually going to, now if you want to think about ways you can make a trapezoid, dividing up into shapes that you know, that's in one way, because a trapezoid can be divided up into a parallelogram and a trapezoid if you go like this. It can be divided up into two triangles if you cut it across the diagonal. Okay, so those are ways to divide up a parallelogram or a trapezoid to make shapes that you already know. So I'm going to go ahead and cut it. Okay, we're going to pretend that this is my trapezoid right here. Let me get a little bit shorter. What I'm going to do with this trapezoid is similar to a triangle exploration. We're going to cut the trapezoid in half. Okay. So I need to actually trace it first. Let's trace it down here, and then we'll cut it in half. Okay, so there's my trapezoid there. I've cut it in half. Cut the height in half, actually. Then we take our half here and put it, turn it around and put it to the side here. So I guess there's, and there we have another rectangle that we're going to tape here. Okay. Let's take a look at our dimensions of our parallelogram now. Parallelogram area is base times height. So I'm going to take this whole base here, and I notice that the base is again consisting of base 2 and base 1. Or base 1 and base 2, it really doesn't matter. Both bases. Let's try that. Okay, so that's the base, the whole base of the parallelogram. Okay. And then the height is now cut in half. So here's the original height here. And then this height is now cut in half. So we right angle from the bottom to the top. Okay. Now that's half the height of the parallelogram, and half the height of the trapezoid. So the height of the parallelogram is equal to half the height of the trapezoid. Now the base the base of the parallelogram is now base 1 plus base 2 of the trapezoid. Okay, so this is the whole base height, the whole base of the parallelogram right here. Okay, so the area of the parallelogram is base of the parallelogram times height of the parallelogram, which in terms of our trapezoid is base 1 plus base 2 times the height of the parallelogram, so times by half height of the trapezoid. Okay. Which when we simplify it gives us 1/2 height base 1 plus base 2. Okay. So it's just the same as up here. So there's two ways to cut up a trapezoid to find out the formula.